Hello, the students of HS First Year Science. I welcome you all to SS College YouTube channel. In previous units, you have learned different laws of chemical combinations, different applications of Avogadro's laws, etc. Today, I will start new unit, states of matter. States of matter. Now, we know that there are three types of states of matter. That is, matter exists in three different physical states, namely solid, liquid and gaseous state. And the important characteristics of these are, we know that a solid possesses a definite size, that is volume, and a definite shape. The shape of a solid can be changed, but it usually requires considerable force. So therefore, solids are generally hard and rigid. And some common examples are iron, silver, common salt, etc. Then liquid. We know that a liquid possesses a definite volume but not definite shape. It takes up the shape of the container in which it is placed. Sorry. Liquid also has a tendency to flow. For example, water, alcohol, milk, oil, etc. Next is our gaseous state. A gas neither possesses a definite volume nor definite shape. A gas occupies the whole of the volume of the vessel in which it is placed. For example, carbon dioxide, oxygen, hydrogen, air, etc. So, however, it may be noted that a substance may exist in any of the three states of matter under appropriate conditions of temperature and pressure. So, as we all know, water can exist in three states of matter, So, ice is solid, water is liquid and steam as gas. So, in general, a substance is said to be a solid if its melting point is above room temperature. So, the point should be noted under atmospheric pressure. A liquid if its melting point is below room temperature and boiling point is above room temperature. And a gas if its boiling point is below room temperature under atmospheric pressure. So these are the characteristics of solid, liquid and gas. But nowadays, one thing is very important, that it may be noted that now scientists are talking about 5 states of matter. In addition to solid, liquid and gaseous state, there are also 2 more states of matter known as plasma and Bose-Einstein condensate, that is BEC. Next is our intermolecular forces of attraction. The forces of attraction and repulsion between interacting particles, that is atoms or molecules, are called intermolecular forces. And these type of forces exist in all states of matter and are responsible for many structural features and physical properties of matter. So the intermolecular forces are weak forces. And these are present even in case of nonpolar molecules. And we know that nonpolar molecules are H2, O2, Cl2, etc. Now the existence of weak attractive intermolecular forces was first proposed by the Dutch scientist Johannes van der Waals, who studied the effect of these forces on the behavior of real gases. So, in his honor, we can say that these forces are called van der Waals forces, van der Waals forces. Now intermolecular forces arises due to the following types of attraction. These are dispersion forces, dipole-dipole forces, dipole-induced dipole forces, and hydrogen bonding. Now number 1, that is dispersion forces or London forces. Now atoms and nonpolar molecules are electrically symmetrical and have no dipole moment because their electronic charge cloud is what? They are symmetrically distributed. But the intermolecular forces may exist even in these nonpolar atoms, such as the noble gases or nonpolar molecules such as oxygen, nitrogen, hydrogen, etc. So these instantaneous or temporary dipole arises, and these distorts the electron distribution of the neighboring atom. Here the atoms are A and B, you see A and B, and here the electronic charge cloud is symmetrically distributed in the first figure, and in the second figure, due to the temporary dipole moment, it distorts the electron distribution. That is why what happened? That is why an induced dipole is developed and known as instantaneous induced dipole. The temporary dipoles of atom A and B attract each other. So these attractive forces are also called instantaneous dipole or instantaneous induced dipole forces, and these are first studied by the German scientist Fritz London. That is why this type of forces are also known as dispersion forces or London forces. So number 2 is dipole-dipole forces or Kisom forces. Now these type of forces are, you see that these type of forces occur in molecules which have permanent electric dipole such as HCl, NH3, H2O, etc. So a nonpolar molecule has separate centers of positive and negative charges. Negative charges, and the ends of the dipoles possess partial charges, and these partial charges are shown by Greek letter, you know, delta. So the partial charges are always less than the unit electronic charge. So these forces arise due to interactions between oppositely charged ends of the polar molecules. So here in figure A, here there are two types of charges, yes, del positive and del negative. So this is actually permanent dipole, and next is the second one is nonpolar molecule. So here there are no charges of positive and negative charges. Now for example, the dipole-dipole interactions between hydrogen chloride molecule are shown in figure, that is here there is a del positive and del negative. So this distribution of electron cloud in HCl, that is HCl is polar molecule, that is dipole-dipole interaction between two HCl molecules. So greater the dipole moment of the molecules, greater the forces of attraction. This effect was first studied by Kisom and is also referred to as orientation effect or Kisom forces. And these interactions are stronger than London forces, but these are weaker than ion-ion interactions because only of their partial charges. Number 3 is here dipole-induced dipole forces. Dipole-induced dipole forces. So these type of attractive forces operate between the polar molecules, and the polar molecules having permanent dipole, we know it, and the molecules having no dipole moment. For example, if the molecule of a substance are non-polar, such as noble gas, iodine molecule, etc., they do not possess any dipole. However, when these molecules come into the neighborhood of other molecules which have permanent dipole, so an induced dipole appears on these non-polar molecules. This is because the electron cloud of the non-polar atom or molecule gets deformed. Why? Due to the electric field of the polar molecules. And this causes a shift in the center of gravity of the negative charge relating to the nuclear charge and resulting in the formation of an induced dipole moment. So, in the figure you see, so as the size of the atom or molecule increases, the influence of the electric dipole also increases. So the forces existing between dipole and induced dipole are called dipole-induced dipole forces. And the above three types of forces are collectively known as your van der Waals forces. And the magnitude of each type of interaction will vary depending upon the types of molecule. That is, the molecule is polar or non-polar. And the next one is hydrogen bond. And I think you have heard the name hydrogen bond. Hydrogen bond is a special case of dipole-dipole interaction. So when hydrogen atom is bonded to atoms of highly electronegative element such as fluorine, oxygen, nitrogen, the hydrogen atom forms a weak bond with the electronegative atom of the other molecule. This weak bond is called hydrogen bond. For example, in hydrogen fluoride, hydrogen atom forms a weak bond with fluorine atom. So intermolecular forces discussed so far are all attractive. Molecules also exert repulsive forces on one another. So when two molecules are brought into close contact with each other, the repulsion forces may also start operating. These are between the electron clouds and between the nuclei of two molecules. So, the magnitude of repulsive forces increases rapidly as the distance between the molecules decreases. So, these are the various types of forces. And next is our thermal energy. Now, what is thermal energy? Thermal energy is the energy of a body due to motion or movement of its atoms or molecules, and it is directly proportional to the temperature of the substance. Now if temperature increases, then thermal energy also increases, and it is a measure of average kinetic energy of the particles of the matter and is therefore responsible for the movement of particles. Then the term is intermolecular forces versus thermal energy of three states of matter. That is, a substance may exist in any of the three states, that is solid, liquid and gaseous. Now the three states of matter arise due to the competition between molecular interaction energy. What? Molecular interaction energy, which keeps molecules together, and the thermal energy which moves the molecules apart. The competition between molecular interaction energy and thermal energy determines whether a given substance under a given condition is a gas or is a liquid or is a solid. Now, when the two molecules are far apart, they move freely independent of each other at a given temperature and pressure. When the molecules come closer, the intermolecular interactions start operating. the average speed of molecules of a gas increases with temperature and their motion becomes more random. Next we come to gas laws. We know that the volume of a gas depends upon the amount of gas, pressure and temperature. So from the study of the behavior of gases, certain generalizations were made, and these generalizations are called gas laws. And these gas laws give quantitative relationship between any two variables when the other two are kept constant. So number one is Boyle's law, and this is the pressure volume relationship. Now in 1662, Robert Boyle studied the changes in volume of a gas by varying pressure at a constant temperature of a fixed amount of a gas, and this relationship is known as Boyle's law. That is, at constant temperature, pressure of a fixed amount of a gas varies inversely with the volume of the gas. That is, mathematically P inversely proportional to V when N and T are constant. N is our small n, number of moles. Then our V inversely proportional to pressure when N and T is constant. So from these two we can write V is equal to some constant divided by P, where V is the volume, P is the pressure and K is the constant of proportionality. So on a rearrangement we can write also PV is equal to constant, similarly P1 V1 is equal to constant, similarly P2 V2 is constant. That is, we can write PV is equal to P1 V1 is equal to P2 V2 is equal to constant. So from this we can write our P1 by P2 is our V2 by V1, and hence the Boyle's law may also be stated as the product of volume and pressure for a given mass of a gas at constant temperature is constant. This means that if the volume of a gas is doubled, the pressure will be reduced to 1/2 of its initial value, and if the volume is tripled, the pressure is lowered to 1/3. And next is practical significance of Boyle's law. And the Boyle's law expresses in a quantitative manner the important experimental observation that the gases are, all of us know that the gases are compressible. Actually, as a result of Boyle's law, you know, air at sea level is dense, but the density as well as the pressure decreases with increase in altitude. For example, the atmospheric pressure at Mount Everest is only about 0.5 atmosphere, just to see, only 0.5. So as a result, the oxygen in air becomes insufficient for normal breathing. This causes what is commonly known as altitude sickness and general uneasiness, that is, feeling unwell, then headache, etc. Therefore, mountain climbers and the Jwans in altitude like Ladakh, you know Ladakh, undergo extensive training to adapt their bodies to low oxygen pressure, or they carry also oxygen cylinder for emergency. And this much for today. Thank you very much. Stay home and stay safe.